Welcome everybody to the third part of the RGBA tutorial series for beginner game developers. In this video, we will be covering palette swapping. So what do I mean by palette swapping? Palette swapping is just one example of a principle in game development of reusing assets in multiple ways. For example, having copies of an asset that have a different appearance or different functionality. The NES, or the Nintendo Entertainment System, that came out in 1984, took wide use of palette swapping. It palette swapped its sprites and background elements to distinguish between different characters or environments by using the same set of sprites. An example of this is the player sprite from Super Mario Bros. And I have this sprite sheet here from Spriter's resource. Now, hopefully Nintendo doesn't send their assassins after me for using their intellectual property for educational purposes, but Nintendo's Nintendo. So if we look here in this bottom left part of this sprite sheet, we can see that there are many different states of a single instance of the player sprite. For example, if it's Mario or if it's Luigi, or if Mario or Luigi has a fire flower power-up, and then if they are under the superstar effect, and depending on what level they are in, if they have that superstar power-up. And you can see that these are the exact same sprite, but the colors are just swapped with different colors to indicate the state of the player. This is done for mainly two reasons. One, to cut down on the amount of assets and therefore size of the game, and then as well as make these kinds of systems less complex to program and develop. And what I mean when I say that is that if we take a look at these sprites, now some of these colors are shared between the different states of the player, but we get like 10 different palettes that Mario can be. And you can imagine that this can get very cumbersome. So instead of having 10 different sprites for every frame of animation, and keep in mind, if there wasn't such a thing as palette swapping, we would have to basically create all of the frames of every single animation with the new color. So instead of essentially having these colors hard-coded onto the images or the textures of the player, we only need one sprite. And then through the program, through the game's code, we can change the colors of the sprite. And in this case, this essentially cuts down the amount of data we need tenfold just for Mario. And I want to show you for a single sprite of Mario, the difference between just using one sprite and all the 10 possible colors Mario or Luigi can be in the game in terms of file size and storage. So here is the just the single sprite we're going to be using in the game engine. And you can see that this file is 217 bytes just for one frame of Mario animation. But one single sprite, if we were to take the literal colors with transparency of one single Mario sprite, such as this one, then you can see that this file is 241 bytes. And the reason why that is because it added the transparency, the alpha channel. So this texture does not have the alpha channel. So that's one thing to keep in mind, is that if you add a fourth alpha channel in your sprites or textures, your sprite is going to be a bit larger just because it needs the size in order to store that alpha channel. So that's why why this sprite is larger than this sprite. But also if we take a look here at all 10 of these sprites, you can see just one frame of animation for all possible palettes of Mario adds up to 2.35 kilobytes, which is a lot considering we really only need 217 bytes for just this sprite. And if we do the math here, you can see that we're saving around 11 times the storage just by using this one single sprite that we can change the color of, versus if we were to use the literal colored sprites. This also makes the project far less error prone and far less complex, as you won't have to keep track of the exact color the player is and then synchronize what color the player should be with what animation you are playing, as the system in which determines the color of the player is completely independent of which frame of animation is playing. There are many different ways you can implement palette swapping with different complexities of sprites. These sprites are very simple. There's only 4 different colors, and in this video we will be covering palette swapping with sprites of 4 or 5 different colors like NES sprites. So here we have 4 possible colors for Mario. We have a background color, a cap and overall color, shirt and boot color, and then the skin color. But in the case of sprites like Mega Man, there are actually 5 different colors. You have a background color, an outline color, helmet, shirt, and then the eye. And the way they did this in the NES is that the NES was limited to up to 4 colors per sprite. So what they did is that they overlaid a second sprite on top of Mega Man for the eyes, but since this method that we're going to be covering in this video supports up to 5 colors, you can kind of get away with using just one single sprite with this method. And the way we're going to be doing that is very similar to the previous video. Pretty much everything we do in this video is going to be the same as the splat mapping tutorial, which was the last tutorial I did in this tutorial series, but for 2D sprites instead of a 3D mesh. And the reason why I'm making these 2 videos, even though they're kind of the same concept, the same thing essentially, is because I want to drive home the point that this can be done with anything, with 3D games or 2D games. It doesn't matter. The concepts still apply. The concepts are still the same between 2D and 3D. And we're going to be doing this by creating sprites that look like this from the original sprites. And we are going to tell the game engine, add wherever there is red, apply a different color as opposed to the green or to the blue or to the black areas of the sprite. Pretty much exactly the same thing we did in the splat mapping tutorial, but instead of dealing with normal maps and ORM maps and base color maps, we're just dealing with, we're using these sprites, these images, as data sources. And that is the main concept I've been wanting to drive home with this tutorial series, is that you can treat images and textures and sprites in your games as data sources, because every single pixel of an image, and this is a representation of an image I have here in this spreadsheet, every single image holds 4 different values. They hold a red value, a green value, a blue value, and an alpha value. And these values are typically on a scale from 0 to 1, or they're represented on a scale from 0 to 1, with 0 being no intensity and 1 being full intensity. So if we look at this sprite here, you can see that there is a 1 in the red channel and 0 in the green, blue, and alpha channel. So we would expect this pixel to be fully red, as opposed to this pixel that is 0 on all channels except the blue channel, so this pixel is fully blue. And of course you can have mixes in between. For example, you could have 0.5 in the red, 0.75 in the green, and you would get some kind of yellowish color. But with our sprites here, we are just storing these values, and we are going to tell the game engine wherever there is full blue, wherever the blue channel is at full intensity, apply a different color versus the green channel might have another different color and the red channel. And then the black channel, we can make another color, or we can make it the black pixels fully transparent. Everything I'll be showing off in this video will be within the Godot Game Engine, but just as the previous two videos in this tutorial series, all the concepts you see in this video are engine agnostic and should work with your software of choice, such as Unity or the Unreal Engine. All right, here I am in a new Godot project. Let's go ahead and let's set up everything to the point where we can start creating the NES sprite shader. So first thing I'm going to do is I'm going to import our sprite sheet here, Mario Run, and remember that we want to import sprite sheets with this color data. So I'm going to import that into the file system, and let's create a new 2D scene. Now that will automatically put us in 2D view. First thing I'm going to do is I'm going to add a sprite 2D node here. And we are going to assign our sprite sheet to the texture here in the inspector. So I'm going to drag the sprite sheet from the file system over into the texture slot in the inspector. And there we have our sprite sheet. Now, if we run this right now, and let's save this. I'm going to save this as main.tscn. If we run that, our sprite sheet is very small and it's up in the corner. And probably the easiest way we can fix that is just by simply adding in a camera 2D node. So I'm going to get a camera 2D node, create that under our base, our root node here. And in fact, I'm going to call this root. So you can see we now have a purple rectangle around the origin of our 2D scene. And basically what this camera is going to do is that it's going to override basically this default camera here that the scene automatically supplies, which you can see with the blue rectangle. And it's going to instead use this purple rectangle. But our sprite sheet is still going to be pretty small. So let's select our camera 2D and let's zoom in. So in the inspector under camera 2D, let's change zoom from 1 to like 5. And that should change both the X and the Y zoom because they are linked together. You can see this icon here. So now if we run our scene, we can much easier see our sprite, but it's blurry. It doesn't look pixelated, and that is because our textures are using they're using linear interpolation. We want to set it to nearest interpolation, and that's going to make it look pixelated. So one way we can do that is here up in the project menu. If we go to project settings and we scroll down to rendering textures, I believe. Yep, here we are. Default texture filter, let's set that from linear to nearest. Now we can close the project settings, and there our textures are looking pixelated like they should. One final thing we need to do to make this setup work is instead of displaying a sprite sheet, we only want to display one frame of the sprite sheet at a time, and we want to play an animation. So the way we do that is we select our sprite 2D node, and then we add an animation player. So now you should have a new animation window opened up down here. If you don't, it might be set to output, or this might be you know gone. You don't see this at all. Should be able to just select your animation player node and then click on toggle animation bottom panel. So we want to create a new animation for our sprite to play. So let's click here on the animation menu. Let's click on new, and I'm going to call this walk. Now we can start animating this, but we do need to adjust a property here in the sprite 2D node to only show one of these sprites at a time. So let's go to sprite 2D node, and let's change here under inspector, under animation, we want to set vertical frames. I think it's either horizontal or vertical frames, we'll see, from 1 to 3, because we have 3 frames here of animation. It's not vertical frames, it's horizontal frames. So let's set horizontal frames to 3. And there we just have a single sprite. And here under the frame property, we can now view the other frames by turning this value up or down. And this is the property we want to animate in our animation player. So first of all, we need to think about how fast we want the animation to look and how long the animation needs to be. So I'm thinking maybe 1 frame every quarter second is fine. We'll see if we need to adjust that later. So since we have 3 frames, this is going to give us a length of 0.75 seconds, because that is 0.23 times 3, or 0.25 times 3. So let's set the length here. Right here is the length of the animation. Let's set this to 0.75 seconds. We also want to make this animation loop, and we can do that by activating this icon here, and now our animation will loop. So let's go ahead and let's set our frames up. With this blue scrubbing element here, we want that to be at 0. Let's set the frame at 0 seconds to frame 0. And we can click on this icon here that has a key and a plus sign. Let's just click there. And it'll say create a new track, property, frame, and insert key, blah, blah, blah. We're not really worried about this, so I'm just going to ignore this and press create. So now let's go to, let's go to 0.25 seconds here, and we can set that right here. We can type 0.25, and that's going to put our 2D cursor, whatever you want to call this thing, at 0.25 seconds. There we go. And now we can go up 1 frame here in the inspector and insert a new keyframe. There we go. And then let's go to 0.5 seconds, and then let's add in our last keyframe. Okay, so now we have an animation. Let's see if it's playing correctly. That looks pretty good. I'm happy with that. So now we have our animation set up. So what we can do now is let's switch back to the output panel, output window here, and let's run our scene. And you can see it's not playing. And that's because we actually need to start the animation like in code. I don't think there's a way you can start it automatically when the scene starts. I could be wrong about that. But I usually just set the animations to play in code. But with that all set up, we can start making our NES sprite shader. So I'm going to make the new shader here under the file system. So I'm going to select our root file, our root folder here under the file system, create new resource, and I'm going to look for shader material. Let's create that, and let's call this NES sprite. I'm going to do it lowercase, NES sprite shader material. Let's save that. And now let's select our sprite 2D, and under the inspector, under material, in the canvas item section, let's drag in our NES sprite shader material into the material slot. And you can see nothing's changed, and that's because we need to supply this material with a shader. So let's go ahead and let's create that shader. So I'm going to do the same thing, select the root directory, create new resource, and I'm going to create a new visual shader. You can of course do a regular shader if you are comfortable with writing shaders with code, but for demonstration purposes, just so you can see how everything connects together in a visual way, I am going to use visual shader. So we'll create that. Now, the first thing we want to change is under mode. We want to change it from spatial to canvas item. Spatial is for 3D objects, canvas item is for 2D objects. So we want to change this to canvas item. And then finally, let's rename this shader. Let's call this NES sprite shader. And then we will create that. And now let's go back over to the inspector with our sprite 2D node selected. Let's, under this canvas item area right here, let's open up our material by clicking on it, and we want to drag our shader into the shader slot here. So I'm going to do that. And you can see it still hasn't changed, and that's because our shader really is not doing anything to change the texture or what you see here. So now, in this bottom window, let's change it from whatever we have open here to shader editor. And let's double click our NES sprite shader in our file system, and that will open it up here in the shader editor. So just to make sure our shader is connected and working properly, let's just set the whole sprite here to just one single color. Now, in the previous tutorials, I discussed that color is, when it comes down to it, is literally just a vector 3 or a vector 4, depending on if you are using the alpha channel or not. And you can see that these node inputs here are different colors. This purplish color indicates a vector 3, and this grayish circle here indicates a float value. So let's get a compose vector 3 node. So I'm going to search for compose vector compose node, or we can scroll down to vector 3 compose, and you can see this node has the same colored output. So let's drag this into here, and our image has turned black, which is exactly what we expect, because remember that XYZ is the same as red, green, blue. And I explained that a little bit more in the previous 2 tutorials I did on splat mapping and on channel packing. But if we set X here to 1, we should expect to get full red, which we do. If we were to set Z here to something like 0.5, we get this sort of pinkish neon pink color. And you can see that we can simply just change the color of the entire sprite here with this one single node. Now, of course, we don't want to do exactly that. So let's go ahead and let's start constructing our shader here. So after deleting that vector3 compose node, the first node we really need to get is we need to get some sort of input into the shader so the shader can get the colors of our texture here. So let's get a color, and here, nope, we need to look for an input node. So let's get this input node. And with input, we have all these different options. The option that's going to be the best for us here is the color input. And you can see here, this is yellow, and that is because this is outputting a vector 4. So this also includes the alpha channel. Now, you can simply just drag this into color, and this is going to automatically convert that vector 4 into a vector 3. But, that doesn't really change anything. But this input node is very important because this gives our shader access to whatever is already in place in our node, in our canvas item. Without this shader would not be usable because there would be no other way to really get the color values from our texture. And we can kind of see this working a bit more. If we click this drop down arrow here, you can see we get our red, green, blue, and alpha channels. So if I were to take the red channel, what this is that this is going to supply a float. So if I were to drag this into color, we should see that the red areas in the texture will be highlighted white and everything else will be black. And you can see that is the case there. And what this is doing is that this is converting the float into a vector 3. Now we can do the same thing with the green channel. You can see our green pixels have been highlighted. And then we can do the same thing with the blue. You can see that is highlighted. Now our texture does not have an alpha channel, but technically it still kind of does, but we didn't really apply anything to the alpha channel. But if we plug this in, we're going to get full white. And that is because our texture has an alpha channel value of 1 across the entire sprite because it has no transparency. So let's get rid of that. Now we want to keep this expanded because we are going to utilize these channels here. Now there's many different ways you can go about applying different colors to these different floats. I'm going to show you 2 different ways, and it's really up to you which way you want to use. One is a bit more simple in terms of the amount of nodes you need versus I think the other one, you do have more nodes, but I could be mistaken, but I think it is a little bit more performance efficient. So let's go with the simpler node setup. What we need to do is we need to be able to define what colors are going to be applied to the red, green, and blue pixels. And we're going to want to be able to do that in code later on. So we need to have some sort of way to pass the shader in, these different colors. And the way we can do that is by getting a color parameter node. Now we have a new color parameter node. And this parameter node, when we connect it here to the output in some way, so let's plug it into color, you can see it's fully black. And I'll explain exactly why that is, but let's select our sprite 2D node. And here under the material and the shader here, you see we have a new drop-down menu here called shader parameters. And this is all the parameters that we create in the shader that we can pass data to. And you can see the reason why the sprite is black is because this color parameter is set to black. So let's name this something a little bit more useful, such as primary color. Now it is very important that you give these an appropriate name, and I would highly recommend giving them underscores, because this value that you specify here is going to be exactly what you use in code. It is case sensitive, so I like naming these with all lowercase snake case. And you can see here under shader parameters, it has changed to primary color. Now that's one little neat thing about the inspector is that it can detect this snake case format and kind of pretty it up here a little bit. One thing I think we should do is give this a default value. So let's enable the default value. Now it's set to white. Now in the shader, we can set this to any color we want to, because later on this is going to be modified in GDScript or in C#, whatever you use. So we can set this to any color. Let's set this to something like this cyan. You can see our full sprite is cyan. So how do we apply this color to the red pixels? I'm going to use primary color for the red pixels. Well, like I said, I'm going to show you the simpler node setup, and that is by using a mix vector 3 node. So what we can do is let's get this node and let's put it in between our color parameter and our output node here. And now you can see it's changed a little bit. That's because this mix vector 3 node is mixing our cyan color with white. Remember that, and you can see here X, Y, and Z is colored red, green, and blue. So you take a look here and you can see that all three of these channels are bumped up to 1, which creates white. So that's why our sprite has turned a little bit lighter, and it's mixing that by a value of 0.5. What we want to do is that in order to mix the cyan color in the appropriate pixels, what we can do is we can take our red channel of our input color node and we can apply it to the weight. And now you can see the white color is being mixed in the areas that our red channel has been defined. But we want to apply the cyan to the red pixels instead. And we can simply just change this output color parameter. Let's change it to B. And now you can see we have our cyan pixels. And if we change this, you can see it changing. So this is definitely working. And basically all we need to do is we need to repeat this for the green and blue channel and the black. So let's duplicate this by pressing Ctrl D. Now let's think about this a little bit. So the black is everything but the red pixels. So because the green pixels are a part of everything but the red pixels, let's plug in this new mix node into the A of this mix node. And let's go ahead and let's apply our green to the weight here of this new mix node, and you can see that the green pixels are highlighted again because the B value is set to full white. Let's create another color parameter. We can duplicate this by pressing Ctrl D. Let's name this secondary color. And let's give this a different default value. Let's set this to something like orange or yellow. Let's plug this into B. And you can see that is working as we expect. And let's get one last mix node. And you're probably thinking, don't we need like 2 more? Well, we don't, because I'll just show you here. Let's plug this output into A, and let's get the blue weight here. And you can see that is mixing. Let's create a new color parameter here. And let's set this to tertiary color. Let's plug this into B. Let's give this a different default value of something like maybe this aqua marine color green. Kind of looks like a zombie now. And the reason why we don't need a fourth mix color node is because everything else that we have not mixed yet is going to be a part of this A slot here. So we can simply just create a fourth color parameter here. And let's call this quaternary color. Let's set this to something like that neon pink sort of. Let's plug this into the A slot of that last mix vector3 node. Now you can see we have a 4-color palette swap sprite shader here. But let's say instead of a fourth color, you want to use the black areas of the sprite as transparency. Now, how can we go about doing that? If you remember, red, green, and blue in alpha are floats. So what happens if we add all of these channels together, specifically red, green, and blue? Let's do that. So let's get a add float node. Here we go. Let's plug in, let's create 2 of them actually. And let's plug the second one into the first one. Now let's take the red channel of our input node, let's put it into B of the first add node, and then let's take green and blue and let's plug them into the second. Now if we view this in our color, you can see Mario is highlighted, but the background is black. And if we were to plug this into alpha, you can see it now has cut away the black pixels and the sprite is now transparent. So let's plug in our mixed color nodes back into the color output. And you can see now we have transparency. But what if you wanted to be able to turn this transparency on and off through code? Well, that's very, very easy to do. Again, if we want to access the alpha channel, if we want to be able to turn it on and off by code, we need to be able to access it somehow. And again, we create a parameter for that. So let's get a Boolean parameter. Now, a Boolean, if you don't know, is basically a binary format where it can be either on or off. So if we, if we plug this parameter into alpha here, you can see what I'm talking about. We now have a Boolean parameter, and you can see it's off. If we turn it on, because it's connected to the alpha channel, now we can see our sprite. So that is how Booleans work. It's basically an on and off switch. But what we want to do is that we want to take this output, and depending on whether this Boolean is on or off, we want to be able to turn these nodes on and off. What we need to do is we need to get a switch node, specifically a switch float node. Now you can see that the Boolean data type is this green node here. So let's put this into the value of our switch node. It is 100% doing the exact same thing, because you can see here that if the value is true, then it's going to result in a value of 1. If it's false, it's going to result in a value of 0. So remember, 1 in terms of alpha is opaque, 0 is transparent. So if we turn this off again, you can see it is fully transparent. So what we want to do is let's just plug in our new kind of alpha mask here that we created with these two float add nodes. Let's plug this into the first one here. And now you can see when this Boolean parameter is true, we get our sprite that has been cut out with transparency. If we set this to off, then our sprite completely disappears. And we want the opposite of that. So the opposite of 0 in this case would be 1, right? Because 1 gives us full opaqueness everywhere on the sprite. So now with this Boolean parameter, and let's name this Boolean parameter something a bit more useful, like transparent. And let's give this a default value of off. And now with our transparent parameter selected, we can turn it on and off. And now if you want to use 4 different colors with no transparency, you can, or if you want to use 3 different colors with transparency supported, you can do that just with this one simple node structure here. Now I did mention that there is a second way I was going to show you on how you can mix these colors, and I'm going to show that to you right now. And it's basically the same thing we did in the last video with splat mapping, where we take the floats here of the red, green, and blue channels and we multiply them by our color parameters. So let's do that. So let's get a multiply vector 3 node here. And let's do it with the red channel. So I'm going to take the float of the red channel, plug it into A of our new vector 3 multiply node, and then take the color of our primary color parameter node, plug it into B, and let's plug that into color. And you can see we get the same result as we did earlier. And we can do that. We can do that with every other channel here. So let's go ahead and let's do that real quick. So I'm going to duplicate this. I'm going to get the green float, plug it into A of our new vector 3 multiply node, then get this color output, plug it into B. Let's take a look at that. Now we are multiplying the green pixels by this color. Let's do the same thing with the blue channel. So I'm going to take the blue output, put it into A, and then this tertiary color parameter, plug it into B. Let's take a look at that. You can see that is working. I'm going to make this node window just a bit bigger. Now, the black pixels don't have a channel. So how can we, get the black pixels? Well, we get the black pixels by doing the same thing we did to get the red, green, and blue pixels all together in one. And that's by adding red, green, and blue channels together. But that's going to give us the red, green, and blue channels. So we need to invert this to get the black pixels. So let's create a new subtract node here, and we want float subtract. Let's create that float subtract node, and we want to take the output here of this add node. We want to plug this into B, and the A value, let's set this to 1. So if we take a look and see what that looks like, you can see now the background is highlighted instead of Mario. So we can plug this in to a new vector3 multiply node. Let's plug the output of this subtract into A, and then our quaternary color into B. And then let's plug this into color, and then now we can see the background pixels have been given our quaternary color. But how do we apply all of these multiply nodes at the same time? Well, that's very simple. We just add the results of all these multiply nodes together. So let's get a new add vector3 add node. And we want to duplicate this about 3 times. So 1, 2, and 3. And then let's connect the outputs to the A as if you have a train of these. And then let's go ahead and let's plug in the first multiply vector3 node into B here of the first vector3 add, the second multiply into the second add, and then the third and fourth multiply into the third add. And now let's plug this in to the color output, and you can see we're getting the exact same result. So you can go about this either way. There's also other methods of doing this, but these are just 2 different ways in which you can do this palette swapping. I'm going to go with the simpler node method here. So let's just plug in our vector3 nodes mix node here back into color. And we are done with our shader. So we can move on to changing the color of the sprite via GDScript or C# through the game logic. So I think the best way to go around this is by creating 2 different classes. We're going to create an NES sprite class, which is going to inherit from sprite 2D. And then any sprite in our game will inherit from the sprite NES class. But we can take the sprite NES class and we can extend it to make a player sprite class. And we can add additional functionality in that player sprite class that is unique to the player sprite. So for example, if we create a ground tile sprite, it wouldn't really make sense to give that ground tile sprite fire flower functionality. So we can keep the fire flower and other power-up functionality to just the player sprite. So let's go ahead and let's create the sprite NES class. So what I'm going to do is I'm going to go here under the file system in our root directory. Let's create a new script. I'm going to create a GDScript script here. We are going to inherit from sprite 2D. And everything looks good, except we do need to rename this. Let's rename this to class NES sprite. Let's create that new class and let's open that up in the script editor. So what I like to do is above extend sprite 2D, I'm going to give this a class name of NES, or let's do NES sprite. We're going to change this later, but just for demonstration purposes and so you can kind of see what's going on, let's give our sprite 2D Mario node, let's give that new class NES sprite script that we just made. So I'm going to take the class NESSprite.gd file from the file system, and I'm going to drag it into the script property here under the node area in the inspector. And now we can start really getting into coding this. So every single sprite we make, we want to be able to change the color and transparency of that sprite. We could make a new scene for every single sprite and change the shader parameters in the inspector, but I think a better way to do it would be to create some parameters in the script that we can change in the inspector here away from the shader parameter. And that's going to give us more functionality later on when we start applying like power-up effects and such to Mario. So let's make some export variables. And export variables are variables we can edit inside of the inspector. So let's create export variables for our 4 different colors and as well as the transparent variable. So I'm going to create a new export variable. I'm going to name this primary color. And I'm going to set this as type color. And I always like to give variables default values. So I'm going to give this a default value of color.red. Or let's give it dark red. So we can see it is indeed changing later on when we apply these colors to the shader. Next, export variable secondary color. Set this of type color. And I'm going to give this color dot, let's give this sea green. Let's make the tertiary color. Export var tertiary color. Set that as type color. And then give that a color of, let's see what different blues we can do. Let's do navy blue. Let's make our quaternary color. So quaternary color, set this of type color, and let's give this gray, like, let's do dim gray. And then let's give one more export variable. So export var transparent. And this is going to be of type bool, because remember, this is going to be either on or off. And I'm going to set this to false. And let me fix my error here, my typo. So now in the inspector, you can see our parameters right here, our export variables. And instead of, changing them down here in the shader parameter, we can, in fact, just, collapse this. And now we've basically give our shader the ability to change the color of our sprite on the fly whenever it needs to. Well, we're halfway there. We haven't done it completely. So what we need to do is we need to change the parameters of our shader here. And let me expand this again. There is a method you can call that you can change shader parameters inside of GDScript. Let's get rid of the process function. We're not going to need it. Let's do the ready function. And the method we're going to be using is we want to get the material of our current node, and then let's get the method set underscore shader parameter, and then make some parentheses. Now, setShaderParameter is going to expect two different variables here. It's going to expect what parameter in the shader you are changing, and then the value you are changing it to. So let's give it the name of the shader parameter. So let's start with primary color. So you want to type this in quotation marks. And remember when I said it's very important what you name these here in the node, in the shader editor graph here. You're going to take this value and you're going to put this value in between these quotation marks. So it's not what it looks like in the inspector, it's whatever you named it here in the shader. And then that is the parameter that we are changing in the shader. So let's give it a value to change to. So I'm going to put a comma after that, and then I'm going to type primary color. That's going to change the primary color shader parameter to the export variable that we set up here. So let's do the same thing with the secondary, tertiary, and quaternary color here. So I'm going to do get material dot set shader parameter. Let's do secondary color this time, and then pass it the value of secondary color export variable. Then I'm going to repeat this for the tertiary and quaternary colors. Okay, that looks right. And then finally, I am going to set the transparent shader material as well. Set shader parameter transparent, because remember, we are getting this transparent parameter node here. And then let's pass it the value of our export variable. So now let's save all this and let's run our scene. And as you can see, Mario now has these colors instead of these colors. So our code is working. The issue with this code, though, that we just did is that it's not exactly scalable. If we just keep setting the shader parameters everywhere in this way, we're going to have a bunch of code duplication. So let's create a new function. And this function is going to be change color or change colors. And we're going to pass in, and in this change colors function, this change colors function is going to expect 5 different arguments, which is going to be a primary, secondary, tertiary, quaternary, and transparency. And then it will set it accordingly. So let's go ahead and let's define our arguments. Now, we can't just name it primary, secondary, tertiary, and quaternary, because if we name it exactly like this, then we're going to get some issues because there's 2 different variables that are named the same thing that are defined in 2 different locations. A very easy workaround for that is just by adding an underscore in front and then doing primary color, and then this is going to be of type color. Then we're going to pass in a secondary color. This is going to be of type color. And then tertiary color of type color. Quaternary color of type color. Transparent of type bool. Not of type cool, of type bool. This function is not going to return any values, so we can set this to void. And then let's just pass it real quick. Now, every single time we change colors, we do need to set the transparent value again, because one weird quirk I have found is that every single time you you change the colors, it will set the transparency back to whatever default value it was. So I like to pass this transparent value anyway. So what we can do is we can just take all of these statements from the ready function, let's cut them, and let's paste them into change. Oops. You can paste them. I pressed Control C instead of V when I selected the pass, so I'm gonna have to type these all in again manually. Now, an important thing to understand, and one thing you need to change, is that this statement right here, instead of the second parameter here for the set shader parameters function, instead of it being just primary color, it needs to be underscore primary color because we are getting this primary color. Okay, so your change colors function should look just like this, and it should work. So every single time we want to change the colors of our sprite through code, all we need to do is we need to just call this function and supply it with parameters instead of having to write all of these statements out like this. And that really reduces duplicate code. So let's, in the ready function, let's call our change colors function. Let's apply it the different arguments. So you can see here it is expecting a primary color, secondary color, tertiary color, quaternary color, and transparent arguments. Let's supply these export variables as the arguments. So primary color, secondary color, tertiary color, and quaternary color, as well as transparent. So now when we run the scene again, you can see it is now, the sprite is still changing to the colors that we defined in the inspector. And this is pretty much all we need for the NES Sprite class. So let's go ahead and let's create a player sprite class to extend the functionality of our NES Sprite class. So under the file system, I'm going to select the root directory and I'm going to create a new script. Now this new script is going to inherit from our NES Sprite class because we want to extend the functionality of our NES Sprite. Now let's call this new script class player sprite, and let's create that. Let's open up that new script. You can see it's extending NES Sprite, so we're going to have the same variables, access to the same variables and to the same change color function, but above extends NES Sprite, I'm going to give this a new class name of player sprite. Let's turn on our walk animation that we made earlier in the tutorial. So what we need to do is we need to access our animation player node. So let's get an onReady variable animation player of type animation player, and let's set that to our animation player node. And you can see it's not auto completing, and that's because we need to give our sprite 2D node here, instead of class NES Sprite, let's give it our new class player sprite. Now in the ready function, let's do animation player and let's play our walk animation. And I think that's named correctly. Yep, it is. So now if we play our scene, It's now playing the walk animation. You can see it wasn't the colors that we were expecting though. And that is because we also, if we want to be able to see those colors, we do need to, again, call the change colors function, and let's supply it with our export variables. And let's run the scene again. And there you can see the colors are applied appropriately. Okay, let's add some really simple functionality for power-up states and stuff like that. So the two power-ups we have is Fire Flower and Superstar. And these are going to just simply be Booleans. Either Mario has a Fire Flower or he doesn't, or he has a Superstar or he doesn't. So let's create some new export variables. Now, you wouldn't want to necessarily set these as export variables, but for demonstration purposes, I'm going to do that so we can turn it on and off in the inspector, so we don't, have to create a whole game and go collect a power up. So I'm going to create an export variable of Fire Flower. This is going to be type bool, and the default value is going to be set to false, as well as a super star of false. And then we also want to set up a really simple timer for the script to change in between colors as Mario has the superstar. We're not going to create a timer object, we're just going to create a simple float variable. And this is not going to be an export variable, it's just going to be a regular variable called superstar timer, and we'll set this as a float equal to 0.0. So now let's get into the actual logic of changing colors depending on the power-up that Mario has. So let's do the superstar first, because that's a bit more complex. We'll get the hard part out of the way first. So if Mario has the superstar, let's make the superstar timer start counting up. And a very easy way to make a timer in Godot without making a timer object is by getting your timer that should be set to 0, or maybe it's not set to 0. Maybe you want to start it from a certain time. So superstar timer, and we want to plus equals. This is going to add to the timer plus whatever the timer is already set to. And every single frame of process, every single time process is called, we want to add to the timer up to 1 per second. And if that doesn't make sense, I'll kind of show you. So let's do 1 times delta. Delta is the time in between each frame. Let's just print this out. Print superstar timer. And let's turn superstar on in the inspector and let's play the scene. Okay, you can see the output of our timer, and it's counting up to a new integer about once a second. Because delta is the time in between each frame in seconds. If we were to set this 1 to 2, it would count up to 2 every second. So let's take a look at what that looks like. So you can see it's counting up much faster. In fact, it's counting up twice as fast. I'm going to set that 2 back to 1. So we've pretty much made a very simple timer, and now we can check this timer to see how far along it is, and then depending on how big the timer value is, we can change the color of Mario. So I'm going to get rid of this print statement here. I'm sure there's a much more efficient, better way of doing this, but I'm going to do a very straightforward way of doing this, and I'm just going to create some if statements. So let's do it so maybe every 0.1 second Mario changes color. Now, if you remember, let's go back to this sprite sheet from Spriter's resource. So I'm just going to worry about the overworld star colors, but right here we can get the color values. So the first color is the current player color, whether it's Fire Mario or Luigi or Mario. What we need to do is we need to check to see if Mario has the fire flower or not. Let's say if super star timer is less than, what do we say, 0.1 seconds. If it's less than 0.1 seconds, then now let's check to see if Mario has a fire flower. So if Mario has a fire flower, we want to set his colors to these colors. So let's get the change colors method and let's get the overalls color. What we're going to do is we're going to get the hex value. So what I'm going to do is make it so we can see paint.net and Godot at the same time. What we can do is to enter the hex value, we need to basically construct a color. So let's create a new color, and in parentheses we can type the hex value. And you can see we can do that if I'm going to have to expand here. You can see one way we can pass in colors is by giving a string, which is what the hex value is going to be. So let's give it a hex value of F7 D8 A5, and that looks good. Again, that needs to be in quotation marks. Let's create a new color, and then let's get the color of his shirt here. And then in quotation marks, let's get that hex value. So that's B53120. And I am getting the hex value from the color window here in paint.net. Right there is the hex value. Let's get the color of his skin. That's EA9E22. In quotation marks, let's do EA9E22. Now, because the Mario sprite does not have a quaternary color, we can simply just set the quaternary color to black. So that's going to be color in parentheses 000000. Now we have black. And then of course we want to set transparent to, we want to set this to true. Actually, let's set this to the value of transparent because we're going to set that in the inspector. Okay, now if Mario does not have the fire flower, so else, we are going to call the change colors function again, but just pass in our export variables from the NES sprite class. So we're getting these export variables under the NES sprite area underneath the player sprite values here. And let's go ahead and let's set these colors in the inspector to what Mario should be. So quaternary color, we can just set to full black. We want transparent to be on. And let's get these colors. So I'm going to get the color of his overalls. I'm going to copy the hex value here. So I'm going to select it, Control C. going to go back, set primary color, and then here I can paste that value and then press enter. I'm going to do the same thing with his shirt. Copy that hex value, put it into secondary color, and then his skin, I'm going to copy that value and I'm going to paste it in the tertiary color slot. So now, if Mario has the fire flower, set his colors to these colors. If he doesn't, then set it to these colors that are specified in the inspector. So we have the logic set here for if Mario has a fire flower or if he doesn't. And again, the first iteration of the superstar colors is what his current color is without a superstar. So I'm going to go back and let's do elif superstar timer is less than 0.2 this time. Then let's change his colors. In fact, let's copy this line here and let's paste it here. And let's start sampling these colors now. So the first frame of the star colors. So I'm going to get his green overalls here. I'm going to copy that value. And then I'm going to replace this hex value here with that new hex value. Get the color of his shirt here. Copy that. Replace this hex value here. And then get that skin. Copy that hex value and then replace the value here. And we don't need to mess with the transparent or the quaternary color value. Let's create another elif. This is going to be if superstar timer is less than 0.3. Then we're going to copy and paste this line here. And the only one we need to change is the overall color. You can see the overall color is the only color that changes in between these two frames here. So I'm going to copy that value and I'm going to paste it in the first hex value. And then finally we have one more frame of the star colors here. What we can do is we can simply just do else, because that will be anything above 0.3 seconds. And let's copy this line. Let's paste it here. Let's get these hex values. That's just 0.00000. And then this hex value here. Put that into the second argument, and then the skin, put that into the third argument. Now, one thing we do need to do is if the superstar timer reaches a certain value, we want to set it back to 0. So this loops over and over again. So let's create another if statement here. And we have 4 different states in which Mario can be in depending on the timer. And we change this state by every 0.1 seconds. So the biggest value the timer should be is 0.4 seconds. So let's do if superstar timer is greater than or equal to 0.4, let's set superstar timer back to 0. So we do want to put this above this, this logic here, so Mario doesn't have like an extra frame for this last color. Not that that's a big deal, but whatever. So this will just reset our timer back to 0 once it has reached 0.4 seconds. So with Superstar on, let's see if this code is working. So I'm going to run current scene, and it appears to be working pretty well. You can see, independent of our walking animation, the colors are changing, which is the exact, effect we want to go for. We're almost done here, but we haven't actually defined a state for if Super Mario or if Mario doesn't have the superstar. So under the process function, we don't need to create an else statement, because if Mario doesn't have the superstar, then this is not going to, take effect at all. We do need to check to see if he does have the fire flower, but we already did that up here. So instead of, having duplicate code, let's create a new function to check to see if he has the fire flower, and if he does, change his colors accordingly. Let's create a new function called, you're not going to want to name it the same thing as your variable most likely, but just for the sake of time, I'm not going to worry about it too much. So a new function, fireflower, this is going to not return a value, so this will have a return type of void. I'm going to create some new lines here. And what we can do is we can just, take this code here, just cut this code out, paste it into there, and instead we can call the fireflower function issues because of indentation. Okay, so we do actually have to name this something different. So let's put an underscore in front of fireflower. And there we go. So we should be able to turn Superstar off now, and let's play the scene. And now Mario has his regular colors. That is working as it should. Let's turn Fireflower on. And Fireflower is not working. That is because we forgot to call the Fireflower function outside of our Superstar logic here. Forgot to do that. So if Mario doesn't have the superstar, then it will skip all of this logic here and then just go to call this fireflower function here to check to see if he has the fireflower or not, and to adjust his colors accordingly. And you can see Mario now has the fireflower colors. And if we have fireflower and superstar both turned on at the same time, again, it's not working. This actually, calling this after causes issues. Calling fireflower after the superstar, because if we have the superstar, then the fireflower function is going to overwrite whatever the superstar function has done. So we need to call fireflower before we do our superstar logic here. So let's try that again. You can see that's working, and that looks like it is working as it should. So that was the basic NES style palette swapping tutorial. I hope you learned something. I hope this was very helpful, and if it was, then like the video and subscribe, because I will be coming out with more tutorials similar to this series that I have been doing. And really hope you enjoyed, and you can take this system and expand it in any way you need to. So thanks for watching, and I will see you in the next video. Take care.